So here we have the pure 2 coordinate geometry, and in the specification, this is the specification. Now remember, this is the international A level. So those of you who did the normal GCSE and not the international one, you would have seen circles before in GCSE. However, your centre would have always been 0, 0. So you would have only worked with your radius. So even though it looks like there's quite a lot of new stuff in here, it's not so new, okay? It's really simple. Right, let's get started. Question 1. Question 1. The circle with centre A passes through the point P with coordinates -9, 8, the point Q with coordinates 15, -10. Given that PQ is the diameter of C, find the coordinates of A. Okay, so first of all, I'm going to draw this as a picture. We have my X and Y. So 15 -10 is roughly here, and then -9, 8 is roughly here. So this, oh, it's a terrible circle. However, -9, 8, and 15 -10. So this is P and this is Q, and they actually pass through centre A. Okay, so that means I've got to find the midpoint of these two, haven't I? So the midpoint of -9 to 15. Okay, so I personally find the difference between -9 and 15 is in fact 24, isn't it? I know that half of 24 is 12, so I take away 12, I get 3. Okay, this is what happens in my head, by the way. This is what happens. So my midpoint so far is 3. Okay, and then between 8 and -10, my difference is 18. What's half of that? 9. 8 minus 9, -1. Okay. However, if you want to, what can you do? You can do -9 plus 15, divide that by 2, you will get 3. Okay, there's loads of different ways. I'm just showing different things. Find the coordinates of A. So A is in fact 3 and -1. And then it says find the equation for C. So the equation for a circle, what do I need? So I've got x minus 3 squared plus y plus 1 squared equals my radius squared. How do I find my radius? Yeah, the centre and any point on the circle, I'm going to use Pythagoras, okay? So what are my Pythagoras? How do I go from 3 to 15? I know this is 12. -1 to -10 is 9. So 12 squared plus 9 squared is going to give me my radius squared. 144 plus 81 is my radius squared, which is 225 is my radius squared. Oh, that's nice, because that means my radius is 15, doesn't it? Square root 225 is 15. So my equation for the circle is x minus 3 squared plus y plus 1 squared equals 225. Remember, it equals my radius squared, okay? Next part of the question. It says, a point R lies on the circle C, given that the length of the chord PR is 20 units. So R could potentially be here, couldn't it? And this could be 20 units long, could it not? But R could also potentially be here, and it could be 20 units long this way. Okay, so R, we know, is going to be, could possibly have 2 different ways. And it says, find the length of the shortest distance from A to the chord PR. So A to the chord PR means we need to find the midpoint of PR and then find the shortest length from A, because this will then give us the shortest length is always the perpendicular bisector of one line to the point. Okay, so how are we going to do that? There's lots of different ways, and we could overcomplicate so many things. But let's go back to basics, okay? If we know P to R is 20, okay? We have a coordinate 3 minus 1, okay? How are we going to do this? So, we know the length of P to A is our radius, which is 15. So we know the radius squared is 225, right? We know the length is 20. We know it has to be the perpendicular bisector, so it has to be the middle. This then becomes 10. So we're then able to find the length of R by double using Pythagoras. So we're going to get 15 squared minus 10 squared is 125. So root 125 is going to give me 5 root 5. And that is the length of A to the line PR. It's this length here. Okay, part D. It then says find the size of the angle ARQ. So now it wants let me just get a highlighter. So ARQ. Okay, so if I was to actually draw this again, ARQ. Okay. What is I want an angle, right? So I want this angle, yes? So what's A to R? We know the radius is 15, don't we? Yeah? Okay. What did we work out? The length of the shortest distance from A to the chord PR. We know that we know the length of the chord is what? 5 root 5. Are we able? We know that this is 5 root 5. Okay. Now, how are we going to find this angle? So to be able to use the cosine rule to find the angle, I need to find the length PRQ. Okay. However, I can find the length RQ because P, Q, and R will form a right angle. And that's because PQ is a diameter, okay? And this is where we use circle frames. So we know that PR is 20, and we know that PQ is, what did we work out? Did we work out the radius? Yes, 15. So this must be 30. Okay, so if we know this is 20 and 30, we're able to work out R. So 30 squared minus 20 squared equals squared minus 20 squared equals 500. So root 500 is 10 root 5. So I know that this is 10 root 5. So now I can use this to work out the angle. Now in the mark scheme, they've done this a different way. However, maybe I'm just completely overcomplicating it. So I'm going to do A squared. So, because what angle do they want? A, R, Q. And A is roughly here, isn't it? Okay. Okay, so we want this angle, but you know what I just realised as well? We don't even have to work out this part here that we just did, because we worked out earlier that this length is 5 root 5. So if I now use this as a right angle triangle, Okay, I'm taking up this part here. So this is 10, this is 5 root 5. I can work out this angle and then take away 90 from it. Okay, so this is going to be 90 degrees minus, this is opposite adjacent. This is tan of 10 over 5 root 5. So let's see what that is. 90 minus tan of 10 over 5 root 5, which is 89.98. Which does not make sense. 5 root 5, 10. Oh, you know why? Because this is opposite over adjacent. 5 root 5 over 10. So 90 minus shift tan. Okay, so this is really good that you always look at your answer and think, does it make sense? Does it not? And this is why sometimes it's best to write everything out so you know you've done it right. So you get 41.8 degrees. And there we have it. There's our angle to 1 degree. Question 2. Here we go. So, a circle with centre at the point 2 minus 1 passes through the point A at 4 minus 5. Find the equation for the circle C. Okay, so first of all, I always like to draw this. Now, I don't need to draw this, but I like to see what's happening. So, I'm going to have my axes, and it's just a quick sketch. My centre is 2, 1, okay? So 2 minus 1, sorry. So here's my centre. And I know it passes through the point A at 4 minus 5. So it's going to pass through this point here. So if I was to draw this as a circle, so let's get this circle going. Oh my, what happened there? There we go. Okay, so here's my circle. Now, with this circle, okay, so here's my circle. Remember, here's my axes, my centre's here, and we know it crosses here, okay? Now, with a centre, we know we have x minus a squared plus y minus b squared. This equals my radius squared, doesn't it? Okay, so they've actually already given us our centre, which is 2 minus 1. So if I'm to write that into the equation, how would I write that? I would write that x minus 2 squared plus y plus 1 squared. Perfect. This equals my radius squared. Okay? Now they've already given another point here, which is 4 minus 5. If we have the centre and a point on the circumference, are we able to find the length? We can find the length, absolutely. If I was to draw a straight line here, remember, you can, with these coordinates, always make a right angle triangle and use Pythagoras. Okay, so going across here, I'm going from 2 to 4. So what does that mean this length is of my right angle triangle? If my x-coordinate here is 2 and my x-coordinate here is 4, what's my length? 2. So I know this is 2 because I'm looking at these coordinates, my 2 and my 4. Okay? Now if you think about my y-coordinates, I've gone from minus 1 to 5. That's going to give me this length here. Minus 1 to 5, what's that? Yeah, minus 4, which is 4. We don't care about the negative because we're talking about length. We're going to square these anyway. Okay? So to find, remember, this is my radius. So to find my radius, so I'm going to do 2 squared plus 4 squared is going to give me my radius squared. So 2 squared plus 4 squared is going to be 20. So 20 equals my radius squared. So therefore, my equation is x minus 2 squared plus y plus 1 squared equals my radius squared, which is 20. So there we go, 3 marks, and I didn't have to draw a picture to help us, but this is just a nice visualization of what's actually happening. Part B, it says find an equation of the tangent to the circle C at the point A. Okay, so if we want a tangent to the circle C, here is a tangent line that I'm going to draw. Here is a tangent, okay? This is a tangent. We want the equation of this line, right? Now, the equation of this line, if we have a look, this is perpendicular to the radius, okay? So when we want an equation of straight line, we need a coordinate, which we have, 4 minus 5, and we need a gradient, okay? Currently, we don't have the gradient of this line, but we can work out the gradient of the radius, and then we know to find the gradient of the tangent, we need to do the negative reciprocal. So, if we have 2 points, how do I find the gradient of the tangent, the gradient of the radius? Yeah, y2 minus y1, so minus 5 minus minus 1 over x2 minus x1. So minus 5 minus minus 1 is minus 4 over 2. This is going to give me negative 2. So if that's the gradient of the radius, how do I find the gradient of the tangent? Negative reciprocal, which is positive a half. Okay, so now I have a gradient and a coordinate. Can I now find an equation of a straight line? Absolutely. So remember, some people do this in different ways. I'm going to use y equals mx plus c. So minus 5 equals a half lots of x plus c. So minus 5 equals 2 plus c, so c equals negative 7. So now if I write this out, I'm going to get y equals a half x minus 7. However, let's go back and read the question and see what form it would like it in. It wants it in the form ax plus by plus c. So so that means I currently have a fraction, and a, b, and c needs to be an integer, and an integer is not a fraction, yeah? So how do I get rid of this fraction? How do I manipulate this? I'm going to multiply everything by 2. So that means every single thing by 2, I get 2y equals x minus 14. Okay, this is where people sometimes mess up, but again, this is GCSE level here. So now we're going to move it all to the left-hand side. 2y minus x plus 14 equals 0. Because that's what it wants. It wants ax plus by plus c equals 0. And there we have it. Well done. Okay, question 3. So, the circle C has centre P, 7, 8. Okay, I'm going to literally write everything on. That's always, if they give you a diagram, start writing things on. 7, 8. And it passes through the point Q, 10, 13. As shown in figure 2. Find the length of PQ, given your answer as an exact value. Okay, again, how do we find the length? Remember, if we've got 2 points, we can treat it as a Pythagoras question by creating a right angle. This is 7, 8, and this is 10, 13. So I'm basically saying, how have I gone from 7 to 10? What is that? 3. And how have I gone from 8 to 13? 8 all the way up to 13 is 5. So now to find the length, I can use Pythagoras. 3 squared plus 5 squared equals my radius squared. 9 plus 25, is that 34? So 34 equals my radius squared. So my radius is the square root of 34. Okay, and it says give your answers an exact value. Can I simplify root 34? 17 times 2. I don't think so. When you put it into your calculator, this is another way to check. You put root 34 into your calculator. If it gives you root 34, you know that you've got it simple. For example, if you put root 8 into your calculator, you'd get 2 root 2. That would be a simple score. This is exact. They do not want a decimal. It then says, hence, write down an equation for C. Well, that's really easy because we know we're going to have x minus 7 squared plus y minus 8 squared equals my radius squared. Remember, my radius squared was 34. So look, we've done 4 marks in 2 minutes. Isn't that beautiful? Then says the line L is tangent to C at the point Q. Find an equation. This is just like what we've done in that previous question. So step 1, we need to find the gradient of P to Q, the gradient of our radius, which is going to be 13 minus 8 over 10 minus 7, which is 5 over 3. Okay? I then need the gradient for the tangent is the negative reciprocal, so that's minus 3 over 5. I have my coordinate, which is 10, 13. I'm now able to find the equation of the straight line. So, for y equals mx plus c, I'm going to get 13 equals minus 3 over 5. Don't know what happened there. Minus 3 over 5 lots of 10 plus c minus 6. So I'm going to get 19 equals c. So I get y equals minus 3 over 5x plus 19. However, if we go back and read the question, it has asked us to put this into a particular form. You will not get the last mark if you do not have it in this form. It wants a, b and c to be integers. So we have to multiply everything by 5. So I'm going to have 5y equals minus 3x plus 95. Is that right? Then we need to move it all onto the other side so that we get a 0. 5y plus 3x minus 95 equals 0. And now we've put it into the correct form. Question 4. Now question 4 is a different style question where we're given the equation of a circle. However, it's not in the equation of a circle form, in like the type of standard form we see. That's okay though, because what we need to do is we know to get something in a bracket with a square, we can complete the square. So our top tip here is to rewrite the equation, making sure we have x squared and then our x's. This becomes minus 10x plus y squared plus 6y plus 30 equals 0. Now what we're going to do now is complete the square on both parts. So, just focus on my x's. If I complete the square here, I'm going to get x minus 5 squared minus 5 squared, which is minus 25. And then if we focus here, we're going to have plus y plus 3 squared. 3 squared is 9, so minus 9. And then remember, we're going to have our plus 30 equals 0. So now I'm going to collect like terms. So I'm going to have x minus 5 squared plus y plus 3 squared. Minus 25 minus 9 is minus 34. Plus 30 is minus 4. So minus 4 equals 0. And now I'm going to move the 4 to the other side. X minus 5 squared plus y plus 3 squared equals 4. So, the question says, find the coordinates of the centre. So what is the centre of the equation? 5 minus 3, perfect, because 5 and minus 3. And the radius of C, remember this is the radius squared, so it's 2. Okay, so remember if the radius squared equals 4, the radius equals 2. Perfect, so that's that part of the question done. Now, remember, if you're struggling with any of this, you need to go back to the chapters, okay, to the chapter video, and then go back to the prior knowledge and all the key skills. So, the y-coordinates of the points where the circle crosses the line with the equation x equals 4. So, first of all, again, what do you think is my first step? I'm actually going to draw a picture. Okay, so you might do that. You might substitute straight away. I need to see what's happening. I like to draw a picture because I like to visualize what's happening. It takes a few seconds. We know this is 5 minus 3. Okay, And we know the radius is 2, so my circle is going to be here. Perfect, I've drawn a picture. And it says the equation x equals 4. So I know that this is 5 here, because that's my centre, don't I? So x equals 4 is going to be here. This is the line x equals 4. Okay, now I can see it crosses twice. We have 2 intersections. So what I'm actually going to do is, I know it's a simultaneous equation, a substitution. I'm going to substitute x equals 4 into my equation of a circle. So instead of x, I'm going to write 4 minus 5 squared plus y plus 3 squared equals 4. However, this is always handy to do just to see what's going on. So here we go. So I'm going to have, what's 4 minus 5 minus 1 squared is 1. Plus y plus 3 squared is y squared plus 6y plus 9 equals 4. So I'm going to have y squared plus 6y. 10 minus 4 is plus 6 equals 0. Okay? It wants the y coordinates as simplified surds. So I know I'm not going to be able to factorise this because it wants it as surds. I also don't know 2 numbers that multiply to give me 6 and add to give me 6 either, so it's a good job really. So I can use the quadratic formula. Okay. I can just put it into my calculator and it will give me the answers. Either way, it's not charging you, it's not marking you on being able to solve this equation, okay? It just wants you to make sure as well you've got it in simplified third form. So, one of my answers for y is minus 3 plus root 3, and then the other one is minus 3 minus root 3. Okay, and I've just used a calculator there for that. And it just says the y coordinates, that's fine. If it asked us for the whole coordinates, I would expect you to do 4 minus 3 plus root 3 and 4 minus 3 minus root 3. I would expect that of you because that's what it wants to coordinates, but it just wants the y. So there we go. Nice and easy 7-mark question. Question 5. The points A and B lie on a circle with centre P as shown in figure 3. Perfect, that's all shown, we've got nothing to write yet. The point A has coordinates 1 minus 2, brilliant, that's there. And the midpoint of AB has coordinates 3, 1, perfect, that's there. The line passes through the points M and P, brilliant. Find an equation for the line. Okay, perfect. So, first of all though, without even finding an equation for the line, I know I shouldn't do this, but if this is a midpoint, can I find the coordinates of B? Yeah, so I'm just going to do that quickly. It's just, I like to, do it. So if I think to myself, if from A I've started at 1 and I've gone to 3, what does that mean? I've gone across 2. So then if I'm at M, what else do I have to go across? 2. So 3 plus 2 is 5. Okay? So then if you think about it, if I'm at minus 2 and I've gone up to 1, how much have I gone up by? 3. So if I'm at M again, how much would I get up by? I'd have to go up 3 again. So 1 plus 3 is 4. Okay? So this is just using like a vector thing, like we've had to go across 2, up 3. Across 2, up 3. Okay? This is what's happening, and because it's the midpoint, I repeat the process again because it's the same gradient. Okay? This also tells me what my gradient is. This tells me the gradient of this line, the gradient of the line AB is in fact 3 over 2. How have I done that without using the formula? Yeah, for every 2 across I go up 3. So my gradient is 3 over 2. Okay, you can use the formula. You could do 1 minus minus 2, which is 3, and 3 minus 1, which is 2. But this is the point of, sometimes you don't always have to learn formulas if you understand what's happening. Really important. So, it then says find an equation for L1. First of all, what do we notice about this line L? It's perpendicular to AB. So if I know my gradient of AB, what is the gradient of L? Yeah, the negative reciprocal, which is negative 2 over 3. So this is amazing. And it wants an equation for L, so we have a gradient, and what point lies on L? Our midpoint lies on L. I'm just going to get rid of this again. Our midpoint lies on L, so we have a midpoint. So we have a point, 3, 1, and an equation. So I can now start writing this equation. So remember, using y equals mx plus c, I'm going to get 1 equals minus 2 over 3, lots of 3 plus c. So I get 1 equals minus 2 plus c, so 3 equals c. So my equation is y equals minus 2 over 3 plus 3. So there's my equation for L. Okay, it now says, given, oh sorry, I forgot the x here. Now it says, given that the x-coordinate of P is 6, so I know P, my x-coordinate is 6, I don't know my y yet. However, if it lies on this line, we've just worked out the equation of the line. So I can substitute that into here, absolutely. So I'm going to get y equals minus 2 over 3 lots of 6 plus 3. So I get negative 1. Do you get negative 1? Okay, so my y-coordinate is negative 1. Okay, so we've substituted in y equals negative 1. It then says find the equation of the circle. So, am I able to start straight away? I've got x minus 6 squared plus y plus 1 squared equals my radius squared. Okay, how am I going to find my radius? What do I need to find the length of my radius? I know what you're thinking. They haven't given us this coordinate, have they? Okay, but be simple. Go back to being simple. To find the radius, you just need the centre and any point on the circle. Do we have a point on the circle? A or B? You can do B, I can do A. We're still going to get the same length. So I'm going to do A and here. I'm then going to draw a circle between A and P. Okay? So from A, I'm at 1 to 6. What's my length? 5. From minus 2 to minus 1, what's my length? 1. 5 squared plus 1 squared is 26. So my radius squared is 26. So that means finally I have x minus 6 squared plus y plus 1 squared equals 26. Please remember to make it simple. Go back to what you know. Don't think, oh, you know, they do this to trick you, but think simply. How do you find the length of a radius? You just need the centre and any point on a circle. And then we can do Pythagoras. Okay, another great question. Well done. Okay, so back to a similar question, I think to, I don't know what question, but previously, isn't it? So here we go. The circle has centre 3, 1. I tell you what questions I haven't seen yet. Sometimes we have circles, then it wants you to find the area of something. Okay, however, that's why you need to draw it, okay? So the circle C has centre 3, 1. What do you think Miss Hayden-Higgins is now going to do?
Draw it.
Yeah, I'm going to draw it. So remember, I like to visualise what's happening. So 3, 1 is roughly here, and the point P, 8, 3 lies on the circle. So there we go. There's my circle. So I have 3, 1. Okay, 8, 3. Perfect. Find an equation for C. Well, first of all, can I start the centre? X minus 3 squared plus y minus 1 squared. Absolutely right, okay? So now this equals my radius squared. How do I find a radius? What do I need?
The distance between the two points.
Yeah, distance between a centre point and somewhere on the circumference. So remember, I can theoretically draw a right angle triangle here. And then from 3 to 8, how far is that? So this becomes 5. That's my length, isn't it? If you think I've gone from here to get to this point. Remember, if you think about, you know, when we did translations, like this is a translation. How have you gone from this point to this point? You've used the vector 5, 2. Because you've got to cross 5 up 2, haven't you? This is what you're going to use for your Pythagoras. It's going to have 5 squared plus 2 squared equals r squared. So 29 equals r squared. So now we have x minus 3 squared plus my minus 1 squared equals 29. I mean, look at that. Under 2 minutes again, and we're doing a 4-mark question. Okay, we haven't even needed a calculator. Next part. It says find an equation for the tangent to C at P given your answer in this form. So remember, we want the tangent. So we want this here. Okay. So what we're going to have, what do we need to find? We need a point. Do we have a point? Yes. And we need the gradient of the tangent. Do we have the gradient of the tangent? No. How could I find the gradient of the tangent? By finding the negative reciprocal of the gradient of the radius. Okay, so I need, because remember these are perpendicular. So the gradient of the radius is going to be, now guys, if I've already done this triangle, this 5, 2, what's my gradient then? My gradient of the radius is 2 over 5. Okay, so my gradient of the tangent is minus 5 over 2. So I've not even needed a formula now. This is where we're at. Do you see how it's so much easier now? Just literally all we're doing is counting and understanding how to do this. This is literally going back to year 7. Remember when we had to draw triangles to find the gradient? So now we're going to have y equals mx plus c. So we're going to have 3 equals minus 5 over 2 lots of 8 plus c, 4 minus 20. So I get 23 equals c. So I get y equals minus 5 over 2x plus 23. Again, it does not want it in, it wants it in this form. ax plus by plus c equals 0. Multiply it all by 2. 2y equals minus 5x plus 46. Move it all to the left-hand side. 2y plus 5x minus 46 equals 0. And there we have it. We've done it. Question 6 completed. And we've done all the basic type of exam questions for this. Some of them, of course, they get harder. They get a bit more innovative. But if you've got this, you've got a really good solid foundation. Well done, everyone.